is revisions on trigonometry ratios. Okay, trigonometry ratios. So trig ratios, there are 3 different types of trig ratios. We have sine, cosine, and tangent. Okay, we have 3 different trig ratios, which is sine, cosine, and tangent. And this can only be talked about in right angle triangle. Okay, this can only be talked about in right angle triangle. You are not going to talk about what's the sine value in an obtuse triangle or acute triangle. It's only in right angle triangle. Okay, so what is the sine value? So for sine value, in this triangle, okay, sine will be the opposite, which is this one, over the hypotenuse. Okay, so for same angle, okay, so for example, sine 50, that's a particular value. Okay, sine 50 got a particular value because the ratio for opposite over hypotenuse will always be the same. Doesn't matter what triangle you really have. Okay, so for example, we have a triangle like that, and we have a bigger one. Let's say that's 45 degrees and that is also 45 degrees. Let's say this triangle is a right angle triangle. You have 10 and 10. And for this one, you just have 1 and 1. That's root 2. That's 10 root 2. Okay, the sine 45 in this triangle give you sine 45 is opposite, which equals to 1 over hypotenuse, which is root 2. Okay, in this big triangle, sine 45 equals to, okay, opposite, which is the 10 over 10 root 2. That also equals to 1 root 2. So, even though it's different triangles, but for the same angle value, you have same ratio for sine, cosine, and tangent. So every time I talk about sine 30 degrees, that's a particular value. When I talk about sine 45 degrees, that's a particular value. Like for example, sine 45 is equals to 1 over root 2. If I talk about sine 70 degrees, that's a true value already. Okay, it's not changing. And cosine is adjacent over hypotenuse, okay, adjacent over hypotenuse. And tangent is opposite over adjacent, okay, opposite over adjacent. So that's the 3 ratios. Okay, for any right angle triangle with same angles, the ratios are always be the same, okay, they'll always be the same. Okay, example 1 is easy. Use a calculator to evaluate the following. Correct to 2 decimal places. Okay, sine 50 degrees. Okay, first of all, you in your calculator, go to the front page. And in this calculator, you will have a setting page. Okay, number 5, setting page. And then you have a document setting. Okay, a document setting. Okay, I have explained before, or if you watch a video, you can see in the video at the beginning the display digit. The display digit is giving you how many significant figures you have, okay? It can show you how many significant figures. So if you set this number too low, for example, only give me 3 digits, like 3 floats, okay? 3 floats. It can only show you 3 numbers, okay? You can't show you the decimals. So you want this number to be higher. Okay, for example, if your answer is 10,000, let's say 1,230.44444. Okay, but if you set that only for 4 digits, it can only show you the integer part. It can't show you all the decimals after that. Okay, so it only show you limit digit. But for this one, if I set 10, it can show me enough. Okay, about 10 numbers showing on the screen. So you can see more digits. And you can find, like, say, to 2 decimal places, it's easy to deal with that. Otherwise, you even can't see decimals, how you can round it. So that's the first setting. The second setting is for angles. Okay, in year 10, this angle will be set in degrees. I'm not sure, like, normally it should be in degrees, but maybe you're using if you have brother or sister, if you're using their calculators like left from last year, they may set that into radian, okay? They may set into radian because in year 11 and year 12, we use radian instead of degree. So there are 2 modes, okay? There are 2 modes. But in year 10, we purely use degrees, okay? We purely use degrees. So don't worry about the radian. We'll talk about radian next year. But in this year, you need to set that into degree and check your calculator, see if that's in degree or not. If that's not in degree, it will be very different answers. Okay, radian degree can give you really different answers. So make sure that setting is correct, and I'll press. You can make default, okay? You can make default, but because I'm still teaching year 11, year 12, I will just press OK. But if you make default, you don't need to change it every time. Okay, it's set for you there, unless you go to change it again. So I will press OK, and go back to the current page. Go back. Okay, so say you have a lot of windows. Can you see I have 1, 2, 3, 4, 5, 1.5 windows, 5 windows. And if I want to see which window doing what, you don't want to press, okay, on your calculator, if you press Control and left, that Control and left, that will give you the previous one. Control and right will give you the next one. Okay, Control left and right is changing the page. But say if you want to see, I want to find a particular page. I want to find page 1. I don't want to click one by one, especially if you have 20 pages. What you can do? Press Control and up. It can show you all the windows here. Okay, it can show you all the windows here. So you can go to adjust which one you want to and which one you want to open. But like say if I want to delete all of them, just press delete, 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 and everything will be delayed. Okay? And I'll press menu and I'll add a calculator page. Okay, I'll add a calculator page. Like calculator is more fun than learning math. Okay, there are a lot of things you can find from this class. And someone told me this class calculator is actually more powerful than a laptop. Okay, so it's a really good one. So there are a lot of functions you can investigate. Okay, so first one is sine 50 degrees. So sine 50 degrees. So where you can find the sine, there's a trig button near equal sign. Okay, you want to find the sine. Sine what? You want to find sine 50. Okay, because you already set that into degrees. Okay, you already set the mode into degree. You don't need to press the degree button. Okay, you don't need to press the degree button. So you can just put sine 50. Well, that gives you cos 40. That doesn't help at all. So you want to see a value. So you press Control and Enter. That's the exact, when you press Control and Enter, you will have this one. And can you see how, tell me how many significant figures are there? 10. Okay, remember when I have my settings is float 10. Okay, that gives me 10 significant figures. If I just set float 3, maybe that only can give you 0.766. Okay, that's the only thing can give you 0.66. So that gives me enough significant figures. And I want to round it to 2 decimal places, 0.77. Okay, cosine 72 degrees. So cosine is in trig as well. Cosine 72. Let's predict if I press enter what it can give me. I guess it gives, you give me sine 18, I think. Oh, it's not. Okay, it's not. Because I can evaluate that into a number, okay, into some form, into this form. But I still want to find the decimals, and I'll have 0.31. Okay, for some reason I can't give me, this one is only show cos 40 because that's the exact way to represent it. You can't find a way into fraction form or thirds form to find the answer for me for that one. But I have a representation, exact representation for cosine 72, so that's why it's different notation here. That one gives me 0.31. And I have tangent 33. Okay, tangent 33. So tangent is here. Oh, 33. And it's still tangent because it's exact. That's the only exact form it can give me. I can press Control and Enter. Give me 0.65. Okay, example 2. Find the value of x in the equation cosine 20 degrees equals to x over 3. Correct to 2 decimal places. Cosine 20 degrees equals to x over 3. First of all, you know that cosine 20 degrees is a number. Okay, it's a number. I can evaluate that. Let's say cosine 20 degrees. I will have control enter, give me 0.94 something. Okay, 0.94. But I don't want to evaluate it now. I don't want to round it so early. Okay, I don't want to round it at this stage. I want to find what is my x into a exact representation. So x equals to 3 cosine 20 degrees. I want to find the expression first. And then I want to put that all together into the cast and to find a number and then round it. Otherwise, if you round it too early and you round it several places during your calculation, then you will reduce your accuracy. Okay, reduce your accuracy of like calculating this. So 3 times cosine 20. So you have cosine 20 already above. Okay, you have cosine 20 above. You don't want to type it again. So what you can do, you can go up and highlight that and press enter to copy that down. Okay, and then press control and enter. Give me 2.82. Okay, 2.82. So 2.82. Okay, number 3. Example 3. For each of these triangles, find the value of the ponomials correct to 2 decimal places. Okay, let's see that this is a right angle triangle. And the angle given to us, okay, the angle given to us, we have hypotenuse is this. Okay, this is hypotenuse. And that one is adjacent. Okay, that one is adjacent. Adjacent and hypotenuse will give me cosine relationship. Okay, cosine relationship. So cosine 31.3 degrees will equals to adjacent, which is 0.05 over b. Okay, over hypotenuse. Cosine equals to adjacent over hypotenuse. So how I can solve for b? How I can solve for b? Because I have b as denominator, so I need to get rid of the denominator first. Therefore, I will times b on both sides. But I know that cosine of that is a value, so I will keep it. Okay, I will keep it like that. And I will divide cosine 31.3 degrees on both sides of the equation. I will have that. Okay, I will times the b to that side first, and I will divide cosine 31.3 degrees on both sides. Okay, on both sides. And then I want to put the values into the calculator now. 0.05 divided by cosine 31.3 degrees. And that will give me 0.06. 2 decimal places, 0.06. Okay, that's 2 decimal places. Next one, I want to solve x and y values. What relationship I will use? Sine, cosine, and tangent, which one I will use? Sine and tangent, or sine and cos. Okay, or sine and cos. So let's see which one is better. Okay, let's see which one is better. There's like it's all correct. Okay, it's all correct method, but like let's see which one is better to use. So let's do sine 30. That's opposite, that's adjacent, that's hypotenuse. So sine 30 is opposite over hypotenuse. So it's x over 5. So x will equals to 5 times sine 30. Anyone know what sine 30? Yeah, a half. Okay, that's a value like exact value. Okay, so it's a half. If you put into calculator, you'll get a half as well. You're not required to memorize it now, but like if you know that, that would be good. So sine 30 is a half. So a half times 5 equals to 2.5. Okay, so you have 2.5 for x values. Okay, 2.5. Okay, after this, I can use tangent or cosine. Or I can use cosine first, and then I can use sine or tangent. Let's see if I use tangent now. Okay, if I use tangent now. Tangent 30 will equals to opposite over hypotenuse. Or opposite adjacent. So opposite is 2.5 over y. Okay, y times tangent 30 degrees equals to 2.5. Y equals to 2.5 over tangent 30. Over 4.33. Okay, 4.33. If I use cosine, okay, cosine 30 will equals to adjacent, which is y, over hypotenuse, which is 5. Then y will equals to 5 times cosine 30 degrees, and y equals to 5 times cosine 30. And that's 4.33 as well. Both of that gives me the same answer. But compare those two methods, which one you think is better? The cos is better, like not only because cos is easy to calculate, there's another reason why cos is better. If in tangent, you will use the answer for x, right? You need the answer for x. Let's have a think. If you make mistake for x, it's possible. So you will have a wrong answer for y as well. But say if you use cos, you don't need to use x at all. It purely depends on y, the 30 degrees, and the hypotenuse. So you give you a larger chance, like you can do a correct answer compared to you using the previous answer. So encourage you to use cosine in this question, but like both of them are correct, and you can get the correct values. Okay. Next one. Next one, you have two right angle triangle, and I want to find the value of x. Okay, I want to find the value of x. What you can do for this one? Have a think what you can do to this one. This is not that straightforward. So, which one? Let's name it. A, B, C, D. Which triangle are you talking about?
ACD.
ACD?
Triangle.
So what I can write?
You can't write anything.
I can't write anything. Then what? Let's say sine 50. Okay, equals to x. Then let's not use sine. Let's use something else.
Oh, the square thingy.
The square thing.
You can't do the square thing.
Let's say if I know the value here, this y value. Can I know the value of x? If I know y plus 10 equals to what? Let's say that's c, d. And I will know this like opposite y, right? Opposite to 25 degrees. And in the triangle ACD, can I find y value? I can't really find the y value, but I can have a representation y in terms of x. Is that correct? Let's say this. I want to set up a relationship between x and y first. Okay, set up a relationship between x and y first. So what ratio I should use? What ratio I should use? Sine, cosine, and tangent. Which one I should use? If I want to talk about x and y. If I want to talk about x and y, which one I should use? 10. Okay, 10. So 10, 50. 10, 50 equals to what? 10, 50 equals to x over y. X over y. So what x equals to? X equals to y times 10, 50. Okay, we have that. I times y to the other side. I want to see x equals to how many y or y equals to how many x. First step. Let's see in this big triangle. What's tangent 25 degree equals to? What's tangent 25 degree equals to? Okay, x over y plus 10. And what is x? X is y times 1050 over y plus 10. Okay, let's times y plus 10 on the other side. I will have y times 25 plus 10 times 1025 equals to y times 50. Okay, I just times y plus 10 on the other side and I'll expand it. Okay, times y plus 10 to that side. Okay, times y plus 10 on both sides and I'll expand the bracket. So 10, 25 times y plus 10 times 10, 25. And what I will do is I'll go 10 times 10, 25 degrees equals to y times 10, 50 degrees minus y times 10, 25 degrees. Okay, I'll move that one to the other side. Okay, move that one to the other side, this one. Move that to the other side. And I have 10 times 10, 25 degrees equals to, I can take y as a common factor. So y times 10, 50 minus 10, 25. Take y as a common factor. Okay, y times a number minus y times another number. That equals to y times first number subtract the second number. And what y equals to? Y equals to 10 times 10, 25 degrees over 10, 50 degrees subtract 10, 25 degrees. Which one? Which line? Which line? First one? At times y plus 10 on both sides of the equation. At times the denominator on both sides of the equation. And that side become only y 10, 15. Catch that close. And this side, I will expand this bracket. Y times 10, 25 plus 10 times 10, 25. Expand the bracket. So it's like that. Okay, so that's the step. Destroying. Okay, same thing. And I move all the terms with y to one side. Okay, all the terms have y to one side. Collect y as a common factor, and then step number subtract that number. That's one number. It's like y plus 10 times a. Tangent 25 is like a, the number. Tangent 25 is the number. So y plus 10 times a is y times a plus 10 times a. Now, because x is the previous line, I haven't expanded x. X is y 10, 50. X is y 10, 50 because we have it here. Y 10, 50. Okay, but the thing is, you use your calculator anyway after this step. Okay, you have, remember in this topic test, you will have your calculators. And you need to use your calculators efficiently. So how we can use our calculator efficiently? Just if you copy something, just wait a moment because I want to show you something. You want to solve for the value of y. Let's go menu. Let's pay. Menu number 3 and number 1. Solve. And I want to solve for tangent. Tangent 25 degrees, that equals to control divide, you have the fraction. The fraction you have, what's the value? Y times tangent 15. Divide by y plus 10. And you want to solve for what? You want to solve for y. You press comma y. And press enter. That's exact. Control and enter. You have 6.427. Okay. Let's say that's 6.43. You directly have the answer. You directly have the answer. Do you have the calculator? Okay, they are copying something. Yeah. use the cast and you have the y value. Okay, you solve out the y value. Then you need to find the x. The y is the polynomial I write on the page. Okay, it's not something the question asked me to solve. So what is x? X equals to y times tangent 50. Okay, x equals to y times tangent 50. So x equals to, okay, what is y? This is y, okay, this is y. All of that is the exact expression for y. Y times tangent 50. Because I use the exact value of y, I don't want to use the rounding the values. I don't want to round it so early. So I have the exact value, okay, at the very beginning I have y equals to the whole thing. That it doesn't really make any difference. But I want to use the exact, and I will press Control and Enter. You have 7.66. If you use the y value, let's say we have this is the y value. That's the approximation y value. What's wrong?
I don't see the y significant by x. And like when you were trying to figure it out.
Here. Why? Why? I need to use that value to help me with my
But you said
calculator.
we would use the exact value.
Yeah, exact value.
But we using it in the calculator.
Yeah, using the calculator because the calculator gives me the exact value.
I didn't see it. Wait, where is it? What do you mean?
I'm solving this equation and I didn't press Control and Enter. I just pressed Enter. That will give me the exact value. That's the exact value. Y equals to that. That whole thing is the exact. And when I press Control and Enter, it gives me this stuff here. Okay, here. That's the approximation value. So what I'm trying to say here is instead of using 6.43, you either use more decimals, okay, give 10 decimal places, or you use the exact value to calculate times another tangent 50 degrees. Okay, so just like, or you can just keep more decimals, like do not just keep 2, maybe keep 4, keep 5. Okay, so that's the point I want to make. In this exercise, in this whole chapter, you will have your calculator. Okay, you need to use your calculator. So I will encourage you to bring your calculator to class every lesson, and you will try to play with your calculators. Okay, you need to get familiar with your calculator now because year 11 you have like massive use of calculators. So you need to learn how to use it now. Okay, example 4. Example 4. Well, example 4 is asking you to find the perimeter of the following triangles and correct to 1 decimal places. Okay, so like if you want to know the perimeter, so you need to know all the lengths. So let's give a name of all of it. X, Y, W, X, Y, Z. Okay. Let's give 4 lengths as a name, W, X, Y, Z. And the only thing you know is the height, which is 20. Okay, the only thing you know is the height is 20. But you know angle 60 and you know angle 25. Okay, if you can find W, X, Y, Z, you can find out the perimeter. You can find out the perimeter. So let's say we have A, B, C, D, E. A, B, C, D. So ABC is a right angle triangle, ACD is a right angle triangle. So in right angle triangle ABC. Okay, you're looking for X and Y. What you have is this one. Okay, 20. Let's say I want to figure out my X. X is the hypotenuse and 20 is the opposite. Therefore, I will use sine. Sine 60 will equals to 20 degrees, 20 meters over X is the hypotenuse. Okay, sine 60 equals to 20 over x. So x times sine 60 will equals to 20. Then x will equals to 20 over sine 60. That's my x. That's how I work on my x. Next, if I want to work on my y, okay, if I want to work on my y, then 20 is the opposite and y is the adjacent. So opposite and adjacent, that will give me tangent. So tangent 60 degrees will give me opposite, which is 20 over adjacent, which is y. Y times tangent 60 will equals to 20. Y will equals to 20 over tangent 60. I'm not going to evaluate now. I want to add all of them and directly put that into the calculator. Okay, there's no point for me to evaluate them one by one. Okay, I just evaluate them, like put the expression there first. Okay, I have my y value now. And I'm looking for w and z. Okay, w and z. That will be similar case. Okay, similar case. So in right angle triangle ACD. Okay, at right angle triangle ACD, we will have, okay, let's see what sine 25 gives us. Okay, sine 25 degree will be opposite, which is 20, over hypotenuse, which is w. So 20 over w. So w sine 25 degrees equals to 20. W equals to 20 over sine 25. X, Y, W. Okay, the last one is Z. The last one is Z. So Z will be adjacent. Okay, Z will be adjacent. Adjacent and opposite will give me tangent. So tangent 25 degrees equals to opposite, which is 20, over adjacent, which is Z. Z times tangent 25 equals to 20. Z will equals to 20 over tangent 25. I have x, y, w, and z. And perimeter equals to w plus x plus y plus z. And that will equals to 20 over sine 60 plus 20 over tangent 60 plus 20 over sine 25 plus 20 over tangent 25. Okay, instead of evaluating them one by one rounded before this, I will put them all into the calculator together and then press enter. And then round it in the end. Okay, I'm trying to do roundings in the last stage. Okay, always do rounding in the last stage. Do not put a rounding number into your calculation to calculate any other things. Okay, so rounding in the last step, we will have over sine 60 20 over tangent 60 plus 20 over sine 25 25. Control and enter, it gives me 124.86. Okay, 124.86. 1 decimal place. Okay, 1 decimal place, 9. 124.9. Okay, so if you rounded early before that and you plus all the rounding numbers, you may only can have 124.8 instead of 124.9. Okay, the true answer. The real answer is 124.9. Okay, so do not do roundings before the last step. Okay, always do rounding in the end. Keep all the form in the exact form and then press Ctrl Enter in the last. Okay, last. A right angle triangular flag is made for the perimeters of a school competition. Perimeters of school competition. The second longest edge, okay, the second longest edge of the flag is 25, and the largest non-right angle on the flag is 71 degrees. Find the length of the longest edge of the flag to the nearest millimeters. So there are a couple of information here. So let's just draw a right angle triangle first. Okay, let's make that obvious. And I'll give you A, B, C. Okay, AB is shorter than BC. Okay, which one should be the longest length, longest edge? AC is the hypotenuse. Therefore, the second longest edge of the flag is 25. So which one should be 25? Second longest, BC. BC should be 25 centimeters. And then the largest non-right angle on the flag is 71 degrees. So which angle is 71? BAC. Because this length, okay, BC is longer than AB. Therefore, the angle A will be larger than the angle C, okay? So the angle opposite to a longer length will be larger, okay, will be larger. So this will be larger than this one. So you will have 71 degrees here. That's 71 degrees. Find the length of the longest edge of this flag. So basically I want to know this one, AC, okay? Longest edge. If you can draw this graph out, I can easily solve that. I have opposite and I want to know the hypotenuse. So I will use sine. Okay, sine 71 degrees will equals to 25 over AC. Okay, AC will be the longest. Okay, I want to find the longest edge, which is the hypotenuse, AC. So AC times sine 71 degrees will equals to 25. AC will equals to 25 over sine 71 degrees. This is in centimeters, okay? This is in centimeters. And it's asked you to crack to the nearest millimeter. So how many decimal places I need? 1. Yep, centimeter, just 1, okay? Because the 0.1 will give you the millimeter. So I will have 21 over sine 71. And that's 26.4. Okay, so AC is approximately 26.4 centimeters. You don't need to convert that into millimeters. This nearest millimeter just tell you is round to 1 dp. Okay, this is nearest to the millimeter, only tell you what is the rounding decimals. Round to 1 decimal places. Okay, so if the unit is in meters and I want to crack to the nearest centimeter, so how many decimals I need? 2. Okay, so 1 meter equals to 100 centimeters, so it will be 2 decimal places. So 0.01 meters will be 1 centimeter, so it's 2 decimal places. It's okay. it's okay, but like it's also okay to keep like this form. Okay, that's it for today.